Okay, guys, so we are finishing 5.7 today. So we'll start 5.7b on page page 301. And this is solving quadratic inequalities. Solving quadratic inequalities. And I wrote in your notes that we've solved linear inequalities before, and they looked like this. For instance, an and looked something like this. Everything was connected. This is an and. And we said this looked like headphones. So we would plot, here's 0. We would plot -2 and +3, and then it would connect like that. Okay. We also had an or, which looked like this once we solved it. X was less than 2, or X was greater than 4. And so you drew your number line again. Open dot this time to the left, since we just had the less than. And then 4 went to the right, and that looked like antlers. This is an or. Okay, some people have trouble knowing, well, what's the difference between when do I just graph an inequality and when do I do this method that we're going to do today? Well, the difference is they're asking you to solve, and there's an inequality symbol. Okay, so make sure you're paying attention to that. Make sure you're paying attention to what they're asking you to do. The first method that we're going to do is graphing, and you should have your notes there. Your notes say to find the intercepts, make a light sketch, then look at the inequality according to the x-axis, and write your inequality from there. So if you take a look at example 4, they have x squared minus 6x plus 5 is less than 0. And the first thing it asks us to do is find the x-intercepts. Well, remember, x-intercepts are the same as solutions. And you guys should know 4 ways to find solutions. You should know graphing, factoring, square root method, completing the square, and 5, and quadratic formula. Okay, so I'm going to try factoring because I think factoring is the easiest. So there's 3 terms. I can't take anything out. The first and third are not perfect squares, so I'll try general factoring. X and X, 5 and 1, and to get -6, both would have to be negative. So that means my solutions would be x is 5 and x is 1. -5x, -1x would give me -6, and -5 times -1 would give me +5. Yeah, that works. So my solutions are 5 and 1. That means my x-intercepts are 5 and 1. So that means I want to plot, I heard it too. 1, 2, 3, 4, 5. Here's 5, and here's 1. Okay, I should have actually, that's okay. All right, and then it says to make a light sketch. Well, again, if I think about graphing, all I really need to know when it says light sketch is, does this open up or down? Remember, we look at this first number. It's positive. There's a +1 there, even if I can't see it. Okay, that's positive, so that tells me my parabola opens up. So it looks something like this. All right, and it doesn't matter. It doesn't have to be picky. It just has to go through those 2 points, and it has to open up. Now I'm going to look at my symbol. My symbol says less than, and I'm going to think about what my graph looks like according to the x-axis. So it's like there's a boundary line right here. And this is telling me that I'm supposed to look less than that x-axis, meaning what is my graph doing below the x-axis? Well, when I look at it, I ask myself, does this part below the x-axis right here, does this look like headphones or antlers? Well, it comes together, so it looks like headphones, so we know this should be an and inequality. And if you look at your notes, remember the and should always be connected. So that means what was my very smallest x-intercept? 1. X should be in the middle, and then my biggest x-intercept was 5. And I should be able to use this exact same symbol. So less than, less than. There's my answer. Okay. All right, so let's try another one of those. Let's look at example 5.
Mommy, why do you put the black one on the red one?
I don't know, you can fix it. Example 5 is 2x squared plus 3x minus 3, and we have greater than or equal to 0. Okay, again, we're going to do graphing, and I need to find x-intercepts first. So if I pull this guy down, You can choose any factoring method, or you can choose any solving method. You can graph, you can try square root method. Well, that's not going to work because I have 3 terms. You can try to factor, you can use completing the square, you can use quadratic formula. That's totally up to you. I prefer to try factoring first. I know I can't take anything out. The first and third are not perfect squares. So I'd have factors of 2, which would just be 2 and 1, and factors of 3, which are just 3 and 1. I don't think this is going to work. 3 and 2 would either give me 5x or 1x, so that's not going to work. If I switch them, this would give me 1x and 6x, so that gives me either 7x or 5x, so that's not going to work. Factoring is not going to work. Okay, all right, so my second favorite is quadratic formula. So A is 2, B is 3, and C is -3. And I'm going to put it into quadratic formula. So x equals -3 plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's see here. If I clean that up, I've got 9. 2 negatives makes a positive. 12 plus 24. 4 times 2 is 8, times 3 is 24. 2 times 2 is 4. Stop. That would give me -3 plus or minus the square root of 33 over 4. Okay? All right, so great. Those are my solutions, and I can't break that 33 down because he's just 3 and 11. So yeah, I wouldn't be able to break him down. Great, those are my solutions, but remember, we're supposed to be putting those on the x-axis. I don't know where that's at, so I need a decimal form of this. Let me grab my calculator. So if I do -3 plus square root of 33 divided by 4, I get 0.69. And if I get -3 minus square root of 33 divided by 4, I get -2.19. Now remember, those are just estimates. That's not exactly what this is. That's just an estimate of where I can put it on the x-axis. Okay? So here's my graph. I've got 0.69 and I have -2.19. Then remember, I'm supposed to make a light sketch. So does my graph open up or down? Well, since A is positive, my graph opens up. So it's going to look something like this. All right. Now, I need to look at the x-axis, my graph, according to this symbol. So this symbol says greater than or equal to that x-axis, meaning I'm asking myself what's happening above the x-axis. All right, well, let's think about it. You've got 2 pieces here. It's going up here and it's going up here. There's 2 separate pieces. Well, that kind of looks like antlers. Remember, antlers normally looks like this, okay? So it's kind of looking like that same thing. So now I know this should be an OR. And you know OR has 2 pieces to it. So we start with this smallest one. Remember, the smallest one was -2.19. That was when I subtracted the square root of 33. So my answer is going to be x is less than or equal to, no, -3 minus square root of 33 over 4. Or, now I'm looking at this one. This one, remember, was, Donovan, wait. This was 0.69. That was when I added square root of 33 over 4. So I have x is greater than or equal to -3 plus plus the square root of 33 over 4. There's my final answer. Okay? Always use the original. Don't use those decimal estimates for your final answer. Okay? We just used those to get an idea of where they were on the graph. So that's an example of an OR. Okay? Go find something to do, please, that is not making noise. We just ate lunch. You are not going to have a snack. I'm sorry, guys. You're going to have to bear with us again today. I know this is seeming like something of the norm. Okay, so that gives you 2 examples for graphing, okay? Now let's turn the page and let's look at example 6. Now let's do an example of algebraically, or some people call this the number line method. It starts out the same way. So example 6 gives us x squared plus 2x is less than or equal to 8. All right, and we need to find x-intercepts, or we need to find, or solve. We need to find solutions. Remember, I always want this guy on the same side. So x squared plus 2x minus 8 is less than or equal to 0. Now I can start to find solutions. Remember, you can use graphing, quadratic formula, completing the square root method, factoring, whatever you prefer. I try to use factoring first.
Oh, I didn't get. Why didn't you get me phone?
Because you're not listening. Go play with your farm set.
No.
Okay, so we've got can't take anything out. First and third are not perfect squares. That would give me x and x. And factors of 8 that would give me 2, 4, and 2. 4x and 2x if I subtract. So this would be a plus and this would be a minus. And that still gives me negative 8 when I multiply. So my solutions are negative 4 and 2. Okay, now with number line method, it says plot these on the number line, okay? Remember, I always like to remind myself where 0 is, but it's not exactly a point that we're plotting, of course. There's negative 4, and there's 2. All right, now you're going to test points. You're going to test points to the left. So if I pick a number left of negative 5, I'm going to test negative 5. Or sorry, left of negative 4, I'm going to test negative 5. I'm going to test a number in between, so I'm going to test 0. And test a number to the right, so I'm going to test 3. Now you could test any number. You could test 100 because it's to the right of 2, but I like to choose the easiest numbers as possible. All right, now what you're going to do with these is you're going to put them back in to your very original. So for instance, if I put negative 5 into the original, I'm saying is negative 5 squared plus 2 times negative 5 less than or equal to 8. Well, this would give me 25 minus 10. 25 minus 10 is 15. Is that less than or equal to 8? No. So I'm going to write a no on this side. That means anything to the left of this is not going to work, okay? Now I'm going to try 0. So we go back up again. 0 squared plus 2 times 0 is less than or equal to 8. Well, that's all going to cancel out. That's going to be 0. Is 0 less than or equal to 8? Yes, it is. So that means anything in between, in the middle, is yes. Now, we should be forming an opinion already of what this is going to be, because if you remember from your notes, it said if you get a no, yes, no, that should be antlers because it's in between. It's in the middle. But I would still go ahead and test over here, because what if maybe you messed this guy up, or what if you messed this one up? All right, you want to make sure that your pattern flows all the way through. So let's go ahead and test 3. We have 3 squared plus 2 times 3 is less than or equal to 8. That gives me 9 plus 6. 15 is less than or equal to 8. No, that is not true. That means this side is no. So like I said, if you look at your notes, we have a no, yes, no pattern. That means it only works in between. Again, you can see where you have headphones. So my symbol is less than or equal to. So negative 4 is less than or equal to x, which is less than or equal to 2. There's my final answer. Okay, headphones should always be connected like this. So that's number line method, an example of headphones. Let's do one more. I want to give you another example of number line. How about 2x squared? This is just an extra example. 2x squared minus x is greater than 3. Now again, I want it to be set equal to 0 first, because anytime I solve quadratic, I want it to be set equal to 0. So that'd be minus 3. First step is still finding the x-intercepts or finding the solutions, okay? So I'm going to try to factor this. Can't take anything out. First and third are not perfect squares. 2x and x. How about 3 and 1? So this gives me 3x and 2x, and I need a negative 1x. That means this needs to be negative and this needs to be positive. Still gives me a negative 3 when I multiply, so that's good. So now my solutions, remember this one's a little bit more difficult. Let's set him equal to 0. That would be add the 3, 2x equals 3, x equals, divide by 2, x equals 3 halves. And, sorry, that's a little messy. That's hard for you guys to see. Donovan, enough. All right, and then this one is easy. That one's negative 1. Okay, so now we're supposed to plot these on a number line. 3 halves, remember that's just 3 divided by 2 is 1.5. So here's 0, here's negative 1, and here's 1, 1.5. Remember, this kind of creates my boundaries, because then I'm going to pick a number to the left. An easy one would be negative 2 to test. I'm going to pick one in between. An easy one would be 0. And then I'm going to pick one to the right. So I'm going to pick 2. And I'm going to put these back into the original. So let's start with negative 2. 2 times negative 2 squared minus, negative 2 is greater than 3. Well, negative 2 squared would be 4, times 2 is 8. 2 negatives would make a positive 2. Of course, 8 plus 2 is 10, so is 10 greater than 3? No. That means this whole oh, heck. Is 10 greater than 3? Yes. Sorry. So that means this whole piece right here, anything to the left of negative 1 should be yes. Now let's test 0. Putting it back into the original, remember. 2 times 0 squared minus 0 is greater than 3. That would all cancel. Is 0 greater than 3? That is no. So that means anything in the middle is no. So you can kind of see your pattern forming. Yes, no. We're hoping we get yes here. So let's test 2. 2 squared is 4, times 2 is 8, minus 2 is 6 greater than 3, yes. All right, so you can see you have a yes, no, yes pattern. That means my graph would look like this, going in opposite directions. That looks like antlers, that's an or. Okay, so that tells me that x would have to be less than negative 1, because it would have to go this way, or x would have to be greater than 1.5, or we're going to use that original 3 halves. Now, some people ask me, how do you know if it's just less than or if it's less than or equal to? And same way over here. Always look back at this original. He didn't have the equal to, so none of your answer is going to have the equal to. If he does, then both of your answers will have the equal to. Okay? So that's the final work for that.